had it,
for them
so
than
when he went to the doctor,
for me.
it like it spread all over his body.
Oh my god.
For
That
them.
was really bad.
That's bad.
When they're dying, you just have a kid.
It's alright though.
Yeah.
He has medication.
Okay. Alright, so let's do this.
Oh.
Also, this is why
I looked up to William.
Okay, so let's do this. Topic 5, statistics and probability. Okay? Statistics and probability. So, today we have about 85 minutes to go through everything we've learned so far about stats and probability. Alright, let's start from statistics. Okay, that's the first thing. Is data analysis. Data analysis. So let's start from the very beginning. How do we analyze data? How do we present data? Yeah?
Whether or not it's discrete or continuous.
Well, let's say just a group of data. Yeah. It could be a measure used to measure discrete or continuous data. If you have a group of data, we've learned how to describe the central tendency using, mean, median. What's the other one? Mode. Okay, let's say go around the table. Stephen, what's the difference between mean, median, and mode?
mean is the average.
Yeah.
Median is this middle point, kind of.
Middle point. Middle point, that's a dangerous definition. Is it always in the middle?
Or it could be the average between the two closest to the middle.
When you have even number of data, yeah, but it's only correct. That's the mean it's only correct under one assumption. What is the assumption?
The data is discrete.
The whole thing is
Discrete.
not necessarily.
Spread out evenly.
Spread out evenly, not necessarily. Median is the middle one. The middle can be the average of the middle two or just the one in the middle under one condition.
That there are three. That there are an odd number of times.
Well, it could be even, then just
Yeah.
look at the average of the middle two. Under one condition. That is either in ascending or descending.
Really?
Yeah. The median is the median only when they are arranged in order.
Oh.
Right? If you just have a random list of data, just pick the middle one, won't give you the median.
Oh.
Yeah, it has to be rearranged so that if the whole thing is in its ascending order or descending order, then the middle one, the middle of that. Okay? Makes sense, right? Because if it's just randomly arranged, then the middle one is just a random number, which is not representing the median of the whole group. All right, mode. Yeah, what about mode? What do we know about mode?
The term of most points.
Yeah, or with the highest
I know.
frequency. With the maximum frequency. Can we have multiple mode?
Yeah.
It's possible, right? Is it possible that every data is mode?
No.
That's not possible. So, okay, so that's a mean, median, mode, central tendency, and also we've learned how to describe the variance.
What if the data is homogeneous?
Can you be more specific on that? What do you mean?
So like at every frequency it's this exact same probability. Will there be a mode? That's what you just said, then there's no way.
If every data share the same value, is that what the question is about?
So like for a data that only has x value of 0 and 1, there's 2 zeros and 2 ones. There will not be a mode, right?
No mode.
Okay.
So variance. What is variance?
Standard deviation.
It's squared. That's standard deviation is squared. And what's the purpose? What's that describing? What does that tell us?
How far far the average,
How far the
average,
No, I was expecting
how
this
far
really
the average point is from the mean?
Yeah.
Squared.
So you're right. Since representing the standard deviation is the average distance between a point and its mean, right? And variance is that squared. So variance is used to describe the spreadness. So it's used to represent the spreadness of the data, right? How it's spread out. And then can standard deviation be negative? Is it possible?
No.
No. So it's just a square of standard deviation. Standard deviation is always larger than or equal to 0, right? It's always larger than or equal to 0. What happens when standard deviation equals to 0?
There's no.
There's just 1 point.
There's just 1 point.
1 point? Really? It's
It has 100% probability.
just 1 point. I mean, do we only have one data if standard deviation equals to 0?
No. It's just that
It's just the frequency. There's only one frequency.
Only one frequency, yeah. So you can say there's only one value, right? It's like the bar. Right? So with x equals to, for example, 5, with the frequency equals to 100. So you have 100 fives. Every data equals to the same value. So every data, the difference or the distance between every data and the mean will be 0 because everyone shares the same value. So that's standard deviation equals to 0. So if, listen up carefully, if every data within a group is increased by 5, does that affect the mean? Yeah. What happens to the mean if every data is increased by 5? Plus 5. Does it affect the median?
Yeah.
Yes. Plus 5.
Does it affect the mode?
No.
Yes.
Yeah, plus 5.
Plus 5.
Oh, so plus 5,
If
right?
there isn't.
Then if there isn't, does it affect the standard deviation?
No.
Plus 5.
No.
No.
It does not, because it does not affect the spreadness, right? Okay.
Cool.
All right, and then let's talk about ways of presentation. In what ways can we present some data? Well, it can definitely scatter plot. It could also be, what's it called? What's that?
Box into.
Box and whisker. Box and whisker. In box and whisker, we have 5 values, 5 dots. And some will also call that as the 5-point summary. So they are the 5 points, or the 5 values on the number line will be the minimum, Q1, Q2, Q3, and the maximum. Okay. So Q1 is the first quartile. It's 25% benchmark of the whole group of data. And then this part is defined as IQR, interquartile range, equals to, what does it mean, interquartile range? What's the definition of that?
It's the 2 times standard deviation.
No.
It's a range from first.
Yeah, so what's the expression?
The 70
Q3
percentile minus the 24.
Q3 minus Q1. Yeah. Whereas the range, in general, just means the maximum minus the minimum. Okay? Interquartile range. All right, and then we also have a diagram like this with value and CF. CF, what's that? Cumulative frequency. Yeah, cumulative frequency. So for a cumulative frequency diagram, the graph will always like this. It always goes up and stops. Okay. So this being the maximum value, and the y coordinate being the total number of the data. So from cumulative frequency diagram, are we able to find out the median? How?
Find the total number divided by 2.
So m plus 1 over 2.
Yeah.
M plus 1 over 2. So m plus 1 over 2 will give you the position for the median. You trace it back. So remember that process? This is something you should have learned 2 years ago. So you trace it back like that. From the position of the median, find out the intersection point with the cumulative frequency diagram, and then trace back to find out the median. Okay? That's how you find out median from the cumulative frequency diagram. All right, so questions? Ian? All good?
Yeah, okay.
Okay. So feel free to raise the question if you feel a bit confused. All right. Let's move on. The next part is probability. Probability. So let's have a thorough review about what we've learned in probability. What is probability, by the way? Chance.
How likely is one?
Likelihood, right? So probability of an event A was the most fundamental definition.
One.
It doesn't have to be one. What is PA? Let's say A is an event.
1 minus p everything.
No, that's not. The what?
Probability of A happening.
Yeah? What's the definition of that?
PA over P. Probability of happening. Probability of A over probability of all events I can ever happen.
Yeah, close. It's the number of outcomes satisfying A divided by the total possible number of outcomes, right? Make sense? So, based on that, you see the word here is number. A number divided by a number, and that number is related to counting principles. So to find out this number of satisfying A and the total possible number is related to counting. No, they're related to counting principles. They're related to counting principles. Yeah, what are counting principles?
Like NPR.
Yeah, it's related to combination. And NPR is actually is combination.
No.
That's-
Permutation.
Yeah, it's related to combination and permutation. So, for example, okay, just to think about it. For example, if I have 3 girls and 4 boys line up in a line, so 7 students in total, line up. Line up in a line. What's probability that? What's probability that the 3 girls and 4 boys are separated as 2 groups? Okay. I think we've seen a similar past paper question like that. So first of all, is the question clear? 3 girls and 4 boys are separate as 2 groups. Basically means you have either 3 girls at the front, 4 boys at the back, or the other way around. That's what it means. Okay, 2 minutes. Have a try. Find out the probability that 3 girls are and 4 boys are separated. wrong?
Should be this one.
What's the reason for that? Can you justify that?
Yeah.
My advice, try to calculate the numerator and denominator separately. How many different ways can that be satisfied? And what's the total number of possible arrangements?
So basically, the girls in one group, the boys in one group. Yeah.
But we have 3 different girls, 4 different boys.
Oh.
Yeah, of course. They're not robots.
Oops. If they are the same name.
Alright, so for this one, the answer equals to, well, the bottom part is easiest. The bottom part is just 7p7, right? 7 of them do permutation, which is 7 factorial, according to the properties of permutation. And the top part is 3 girls, that's 3p3, times 4 boys, 4p4. Times, what? Do we have to times by 2?
Yes.
Why?
There can be two
Yeah,
different
either boys at
arrangements.
the front or girls at the front. Exactly. Don't forget that too. Alright, let's do the calculation by ourselves without using the calculator. 3p3, what is that? 3 factorial. So it's 3 times 2 times 1. And then the 4p4 is just 4 times 3 times 2 times 1. And times by 2?
It's 32 over 2 over 35. That's right.
Yeah, but Stephen, remember it's not always about the answer.
I know.
We do have method marks. And then 3, 2, and 6. 4, 4, 3, 3, 2, 2, 1, 1. Okay. So on top we have 1 times by 2. At the bottom we have 7 times by 5. That equals to 2 over 35.
Mr. Bean,
Yeah.
what did you say? Because you looked at mine and I was missing something.
You missed the 2, I think. Just now.
No,
you
I
did.
had that.
You had that? From here? Oh, over there. Okay. Then you got it right. Yeah, so this is what it means by using counting principle to find the probability of a certain event. Yes.
Can you write down the equations for NCR and NPR?
For NPR, NCR, you do have the formula on your formula booklet involving factorials,
Oh.
right? But you should also know the properties of NPR and NCR. So NPR, first of all, equals to, we can have a quick review, n factorial over n minus r factorial, and NCR equals to n factorial over n minus r factorial times by r factorial. Both formulas are provided on the formula booklet.
Oh, by the way, why wouldn't 2 over 7c4 be wrong?
2 over 7c4.
Yeah.
Why is that?
Because
For this question, right?
yeah.
Okay, can you just 2 over 7c4? What's the meaning of 2? What's the meaning of 7c4?
Wait, I thought I got 7c4.
So that's my point. They might have the same answer, it's easy to check, but are you able to justify your work following the definition? Unlikely. Right?
Wait, how did I come up with that?
Yeah, how did you come up with it?
And then 30.
Okay. Alright, think about it, let us know. And then, it might be a coincidence you got it right. So in this case, some special cases. For example, special cases, NPN. What is that?
N factorial.
Yeah, n factorial. By the way, you need to know how to simplify expressions involving factorial. For example, if I have n plus 2 factorial over n minus 1 factorial, what does that equal to?
plus 2 times n plus 1 times n.
n plus 2 times n plus 1 times by n, right? It's a cubic expression. Yeah, that's right. Just be aware. All the rest are cancelled out. Right? Okay, and then that's just an example. And then so NPN, and what about NCN?
1.
Yeah, it's just equals to 1. Just special cases. Okay, so that's combination permutation. Keep that in mind. All right, and then also probability. We also learned that PA prime. A prime means A not happening. And compare that with PA. What's the relationship between these two events?
1 over
1 minus.
Oh, yeah, 1 minus.
1 minus, or they add up together equals to, what's the sum of them? 1. Yeah. It's either A or not A. It's either A or not A. Okay. And then we also have compound events. Compound events, let's say A union with B. What's the probability between all of these compound events? A union with B. We do have a formula on the booklet, but can you think about it?
It's
it's-
shared into like
It's PA plus
PA.
PB minus PA union B
Plus PB
inches.
minus PA intersect with B.
like that?
Yeah.
Why?
Just draw the Venn
Otherwise,
diagram.
the
and you can
common
understand.
area would be counted twice.
Common area from the Venn diagram. Venn diagram. So by the way, if we have two events, A and B, can we always draw this Venn diagram? Is this Venn diagram always legit? Yes, that's true. So A union with B is referring to this part. So there will be A plus B, and take away the double counted overlapping part, which is A intersection. Okay. And then we've also learned that two concepts. One is independent events. Yeah, independent events. So Aaron, what does it mean if I call two events to be independent?
And one has no second.
How do we test? How do we test for that? Anyone?
PA in B equals PA times PB.
Intersect.
Yeah.
So let's put it down. It's important, okay? The tests for independent events could be PA intersecting with B equals to PA times PB. You know, if A and B both happens, the probability just equals to PA times PB, then they're independent. Or we have another test, that is PA given B. What's it called? This bar here. Conditional probability. Which one is the condition? Is it A or B? B is the condition. So if PA given B equals to PA, if that's the case, if given B happens, the probability of A happens just equals to the probability of A happening. That means it's not depending on B, right? If it's not depending on B, that means the two events, they are independent. And by the way, this one, for conditional probability, we have a formula that is PA given B equals to PA intersect with B over PB. Okay? So it's given that B happens, right? So the denominator will be the probability of B. So under the condition of B, or within the B bubble, what's the probability that A happens? So it's A intersection B on top. It's given. Given. That's the phrasing. Or you can see the word given, or under the condition, or when. When you see those words, that's an indication of a conditional probability. Okay? Alright. And then we also learned one thing that's called mutually exclusive. So for mutually exclusive events, what does that mean, Stephen?
The PA intersect with B will be 0.
Yeah. It only means PA intersect with B equals to 0, which means A and B will never have an overlapping part within the Venn diagram, which means they will not happen at the same time. Lewis, can you give me one example of a pair of mutually exclusive events?
Number of birds in the price order.
No, actually they can be related.
What?
Yeah, you don't know that.
Mutually exclusive though.
Mutually exclusive is not the same as independent.
Yeah, but like.
You know what's really mutually exclusive? Me and my chance of getting accepted by any of the good, better schools. That's mutually exclusive. Boom.
Ian, can you give me a pair of mutually exclusive events?
Let's say I use odd ink in the pen, then it's mutually exclusive that there's still ink in the pen.
Oh,
Say it again?
Yeah, that doesn't make sense.
the event that he used all the ink in a pen, and the event that the pen still has ink.
Yeah, that's all.
Because if you use all your ink, you cannot have any more ink in the pen.
So you're trying to say two events. One is we have ink in the pen, and the other is we have no ink.
No, one is I used all ink. One is
Yeah, so with or without ink, right?
yeah.
Within the pen. So yeah, they're mutually exclusive because they cannot be true at the same time.
Yeah.
So it's not complicated. It could be two events. The first one is Aaron being the first one comes into the classroom. The second one is Ian being the first one comes into the classroom. Mutually exclusive. Okay? And then also it could be, the boys or stays as a group. That's one event. The second event is the boys, they don't stay as a group.
So one can happen.
They cannot,
Happen at the same time.
they cannot
But-
both happen at the same time. Mutually exclusive. Okay, so continue. And then to represent or examine all these probabilities, besides Venn diagram, which is a tool that we've learned a while ago,
Animation kit and animation kit that makes the
we've also learned tree diagram. What does tree diagram mean, Stephen? A tree diagram.
It's basically you start out from like one point
Mm-hmm.
and you expand out to different possibilities.
Yeah. Like that, right?
Yeah.
And then we could further develop that. So for the tree diagram, okay, what kind of general properties can we find within the tree diagram?
You can find different end results
Mm-hmm.
and
I mean,
probability to get those end results.
it shows you all the possibilities, right? A full tree diagram. And then for each branch, can we have a probability for that? Let's say if this is P, what's this one? If this one probability is P, what's this one?
1 minus.
1 minus P. Right? And then, so for example, if we have 3 of them, then 3 probabilities add up together should equal to what? 1. Okay? And then for tree diagram, just need to pay special attention to whether it's with or without replacement. Remember those type of questions? If you pick out something, then if you don't put it back, then the denominator for every step will decrease by 1. Right? Because the total number of possible outcomes decrease by 1. If it's with replacement, let's say when you draw a bubble from the box, if you put it back with replacement, that means every step the denominator they should have the same value. Okay? So pay attention to with or without replacement. All right, that's about the probability. Okay, let's see what else I need to address here. Any other questions? Ian? No? So those are the basics. And then we can move on to the more advanced stuff. All good? Yeah? Okay. Let's move on to part 3. So, part 3 is about discrete distributions. Okay, discrete distribution. So, discrete distribution, you will have a table of value. Like with x, and p is x equals to x, and let's say we have 0, 1, 2, something like that. For example, let's say the probability if it's representing the probability of number of siblings of each student, number of siblings you have, and then if I have 0.2, if I have 0.7, what's the missing one? 2.1? Why?
1 minus 0.2 minus 0.7
Yeah, this one has to be 0.1 because the 3 of them, the sum, must be equal to 100%, which is 1, right? Keep that in mind. And then we also have another concept. It's called expected value. Or just EX. Expected value. Ian, how do we find the expected value of this distribution?
You add up all the numbers. Oh, you times the numbers by the probability.
So in this case specifically, what should we do?
0 times 0.2 plus 1 times 0.7
Yeah,
plus 2 times 0.1.
exactly. That will give you the expected value. And then for expected value, we do have a formula. It's the sum, sigma, of P x equals to x times x. So for each value times its corresponding probability and then add up all the terms. Steven, what's the meaning of expected value?
It's kind of like the expected. It's sort of related to the mean.
It is
Like, if you think of it as that way.
If you choose a random one, it'd be expected to be that value.
It is.
the mean.
It is the mean. Yeah. It serves as the same purpose as the mean. Gives you an average. Okay. So that's about this kind of discrete distribution table. And also, the next part is, for discrete distribution, we have a very special case that's called binomial distribution. Binomial distribution. Binomial distribution is under the discrete distribution umbrella. So for that binomial distribution, we have x is binomial distributed with n and p. By the way, you should be able to locate the functions on your GDC. Okay, Louis, what's the meaning of n and what's the meaning of p?
N is like the total number of times the tested value. Not tested,
Total number of trials.
And then P is the correct result.
Probability of success.
Yeah, probability of success. You have to be familiar with the terminologies. Success. Okay, get used to it. So, I mean, of course, what is success depends on different contexts of the question. You have to be able to identify. And in this case, if it's binomial distribution, we do have the formula for p x equals to a certain value, d capital X. That equals to, I think it's all the formula booklet, right? That formula, is it?
Yes.
I think it is. So it's the number of ways to choose x out of n times by p probability of success to the power of x times by 1 minus p to the power of n minus x. Yeah. Binomial. Quick question for all of you. How can we identify a situation which involves binomial distribution?
There are only two possible outcomes.
Only two possible outcomes. And
Number, if they mention the number of trials, we ask for the number of trials.
if they have the number of trials,
They talk about like a certain, like how many times the thing was performed, or like if they want you to find how many.
that's the requirement, but also we need to have a clear idea. It's either this or that, right? It's success or not success. It's either satisfies the requirement
By
or not satisfy requirements. A binomial situation. You know, we've seen them many times. And the first part of the question is about a Poisson or normal distribution. And then followed by, they have 10 trials based on the previous result. How many times can we, what's the probability of passing the test 3 times? Something like that. So it can be easily integrated with other distributions, which we will talk about in a sec. Yes, Aaron, question?
so what's binomial coefficient? Like
Coefficient? We don't have binomial coefficient.
yeah, but
You're talking about this one?
oh no. Oh, I guess
Yeah, this one is talking about, yeah, what's that? What does that mean?
there's an exam I have that question. And I forget.
Is it a vector?
No,
it's
it's
NCR.
it's the combination.
It's combination, right? So this one is NC X. Okay? The number of ways to choosing X out of N. Okay. So that's binomial. That's binomial. All right. Let's move on to the next part. Finally, we can talk about normal distribution. 4. So, yeah, what is normal distribution?
It's distribution when there's a curve that goes like that.
What's that called?
I don't remember.
Taco. What's that fast food chain?
Taco Bell.
Taco, so what kind of shape? Bell curve. Taco Bell. So it's a bell shape.
That's an interesting way to remember it.
Okay. It's a bell shape. Is it just n in bell shape, Louis? Is it just n in bell?
No, Taco Bell.
Is it just n in bell? What's so special about this bell? Think about it. What's so special about this shape?
So you know the mean right away because that's the Thomas bell, right? And then you know that when you integrate the entire shape, the probability of that is 1.
Okay, yeah, that's actually correct, but hold on. I mean, if you look at this, graphically, what kind of feature do we have? It looks like a bell, what else? Anyone? We don't have, actually you're right, it does have an asymptote. That's the right terminology. It goes getting closer and closer to the x-axis. Yeah, what else?
Middle line, the mean, median, and
Because the whole thing is
even.
close.
It's
Symmetrical.
about the mean.
It's symmetrical, and that's important because many times we do need to apply the property that it's symmetrical. Like Aaron, the question you posed within the group, you have to use the fact that it's symmetrical. And then because it's symmetrical, so the top, the vertex, we will have a vertex corresponding to the x value, which is the mean, which is the median, which is also the node. Okay? And then we know that the whole area underneath equals to 1. Area underneath equals to 1. Okay? So that's some general idea we should know about normal distribution. And then for normal distribution, how do we present that?
I mean, not for all, like the area equals 1.
Yeah, for all. Normal distribution, area equals to 1.
That's for the z factor.
Well, always for every distribution. The area underneath represents the.
But what if it's like about height? And it's like, what is it talking about?
We're talking about the probability.
I guess that's the
So,
x-axis.
yeah, the x-axis is the value, the y-axis is the probability, not the value of the data. It's important to know that. Okay, and then how do you? I mean, for binomial distribution, we use this notation. How do you represent normal distribution? Yeah.
Really long form.
So just n. And what do we have within n? Normal distribution?
Z.
No.
Mu.
Mu.
Standard deviation.
Standard deviation square.
The variance.
So variance over there. So when you describe it, just put it like this: the square of the standard deviation. And then, yeah, the mu. What's mu?
Mean.
Yeah, mu is just the mean, median, mode. Okay. All right.
If they give you the standard deviation in the question,
They will always put a square on top of that.
would they say the standard deviation is this square, or would it this,
They will tell you the standard deviation.
and then you have to split?
I mean, when you write notation like this, you put the square on top of the standard deviation.
But
In the calculator, just put in the standard
in
deviation.
the calculator though, it's in the calculator standard deviation.
Yeah, exactly.
Wait, so what?
The square.
No, you just put in the standard deviation. Yeah. Okay, continue. So in this case, if I want to, oh, by the way, if I want to represent the area all the way to, let's say, a certain value A, how do I present that? I want to find out the area from the left tail all the way to A.
No,
It's smaller than
Oh, okay. I'm looking at I heard several answers. So norm CDF.
X is smaller or equal to
Mm-hmm. That equals to area, right? What else? What else can we do?
1 minus x is larger than
Well, if I just put this part, well, I know you talk about the other part, but let's focus on this part. Probability of x is less than or equal to a, right? Equals to the area. Now, everyone, look at the board. Which one is correct?
bottom.
Which one can we actually write down on your paper?
The bottom one.
So what about this one? This one is also quoting the command.
I mean, it turned out.
It's
It's computer.
on the marking scheme. It says that if the I think there won't be penalized if they're using calculator notation within the steps, but if you express it as a final result, there will be penalized.
If you cannot express that as the final result,
No, if you use the calculator form to express the final result, you will be penalized.
so my advice, I mean, you should know this command because you need to use the command term on your calculator, but Aaron, you shouldn't put that down as part of your work because you always use this one to show your steps. Okay? So that's computer language. Computer language is important for you to get the right answer, but you cannot put it down as part of your work. Okay, and then you're right. That also equals to 1 minus p x is larger than equal to. Okay? Right? All right. So how do we find out the area between two of them? So let's say this is A, that's B, and that's a normal distribution. Let's make it non-symmetrical. That's A, that's B. What should we do here?
That equals to
What about area? Area equals to?
p is less than or equal to b, but also larger or equal to a.
Px is
Larger or equal to a,
larger or equal to A.
less than or equal to
We can put that together.
b. Yeah.
No, you cannot do that. Oh, you're saying that like that, right? Okay, which is fine. And then what I mean, physically, what should we do? Practically, yeah.
So you want to do 1 minus the probability of sorry.
And with normal distribution, if you have A and B, you can just plug the lower.
You can just plug in, yeah. You can actually plug in this as lower and upper.
Do it for b and then you minus a.
Yeah, you can also do that for x is less than or
You
equal
do
to b, minus probability of x is less than or equal to a, right? Okay. Just bear in mind both methods will work. Okay, and then we have standardized. Standardized normal distribution. So, Stephen, what is standardized normal distribution?
It's a normal distribution with a standard deviation of 1 and the mean and mode at 0.
Yeah. So standard deviation basically, the graph looks like this. You know, that's the y-axis, and then mean median mode 0, and so basically it's normally distributed with 0 and 1, right? So that's the standardized normal distribution, and we can say that's z actually. Okay. All right. So what's the relationship between the x and z? We have a formula. What's the formula?
X minus z equals x minus mu.
Z equals to x minus mu
Over standard.
over standard deviation. tell me what's the use of this equation.
You can use the z is found by, so you can find out z.
Give me a situation in which I can apply that. Give me
Okay.
one example.
For example, there's 150 students, and the probability of 150 students and of like passing a math test is 0.6, and you have the mean. Then you just put 150 into the original normal distribution to find out the z. No, you put 0.6 into the original standard distribution to find out the z.
Okay, let's simplify that. So let's say
I'm not going to be able to teach anyone.
for a certain normal distribution, you know the mean provided. You know the standard deviation provided. Okay? What you need to find out is, given the area, this is the key. The area is what? Area provided. Okay? We're talking about general situation. You have the area. What do we need to find out here? What is not provided? Yeah, the x. That's the unknown. Okay, so this is what you need to remember as a general prototype in your mind, so that you just fill in the blanks for a certain question. Just think about does it match this pattern? And then if that's the case, okay, Stephen, now you can help me out here. You know the area, you know the mu, you know the delta here. How do we find out the x?
You use inverse normal.
Inverse normal. So this is GDC language, right? The inverse normal.
Would you write that in the marks scheme?
No, you can't.
So how would you show you're using inverse normal?
So in this case, you can say by looking at standard normal distribution, or just as long as you have the value z, or have the value, they will give you the value. Okay, and then what do we have?
You have the area.
Yeah, we put in the area, right? And then
Area, mean, and standard deviation.
Put in the area, mean, and standard deviation, and then
you can get
the x. Get x.
Yeah.
Yeah, that's true. But sometimes if you have the x, have the mu, or missing the standard deviation, or missing one of them, you can also use the, if you don't know both of them, you can always guarantee to use the area and the mean, which is 1, the standard deviation, which is 0, right? The mean equals to 0, the standard deviation equals to 1. Use that to find out the value of z, okay? So that's a more general case. So this is less demanding, right? As long as you have the area, only depend on the area, you always find the value of z. And from z, you can find out, this value within that equation. And then, with the value of z, you can use the mu and the standard deviation to find out the value of x, or any missing. Okay? So that's the process of applying standardized normal distribution. All right. And then just bear in mind, the whole normal distribution is a symmetrical bell-shaped distribution. So the left-hand side is just 0.5, the area. The right-hand side is just 0.5. Okay? All right, any other questions about normal distribution? No? So this one actually a more standard way is to say is z is distributed like that. All right, and then let's move on to other types of distribution. So we actually, so far we talked about two of them. We talked about normal distribution, we also talked about binomial. What's the next one? Poisson distribution.
Poisson.
Yeah, not Poisson. Poisson distribution. And then number 5. So for Poisson distribution, what's the difference between Poisson and normal? Can someone tell me the largest difference?
There's no boundary.
What else?
It's a graph.
Okay, we also have a graph over there.
It's a graph, it's not a boundary.
Yeah, what's the biggest difference? Fundamentally, for normal, can be used to describe a continuous data, right? Like the height, something that can be measured, the height, the weight. But Poisson distribution can be only used to describe discrete. So only discrete. So lambda, can someone tell me the definition of lambda? What does that mean?
It has to be integers.
Yeah, I mean, what does it mean? I mean, they're integers.
So mean.
The what?
Lambda doesn't mean.
Lambda does mean? Really? So what's the practical lambda? What's the meaning of that within the Poisson distribution?
Like the event,
The meaning of lambda.
Say that, yeah?
the event,
The what of the event?
probability of
The
event.
probability event? Is that what lambda is?
No.
The expected number of occurrence of a certain event within a certain sample size, right? A certain group. So for example,
Expected frequency.
yeah. So for example, if it's about a quality check, for every 100 number of bottles of Coca-Cola, I expect one of them to be with a defect. Then lambda will be 1. So lambda is always, it's always about the expected number of. It's about expect. Expected number of something within a certain size. If that size doubled, what happened to lambda? It also doubled, right? If that size tripled, lambda triples. And then, so it's number of successes or expected value within a fixed interval. Within a fixed interval. All right. So also, Aaron, you're right. It's also about expected value. I'm expecting that number. So in this case, the expected value of x will be lambda, and the variance of x will also be lambda. Okay? So that's for Poisson distribution. And then we also have the fact that for Poisson distribution, the probability of x equals to x equals to lambda to the power of x times e to the power of minus lambda over x factorial. For x equals to 0, 1, 2, so it's discrete. So this formula, I believe, can be found from the formula booklet, right?
Yeah.
Yeah.
It's a similar formula for binomial that we did right now.
For binomial, it's a bit different. We don't have similar one for binomial.
No, I mean like
Is
they
this
give you.
one?
I mean they give you the.
This is binomial.
No, I mean they give you the expected values and p.
Oh, right. For binomial, the expected value is n times p. We didn't say that. Yeah, but yeah, they need to added to there just for the record. Yeah. For binomial, we know that expected value equals to n times p, and the variance equals to mp times 1 minus p. Okay, so that's for binomial and this one. And then, in this case, we also need to know how to locate a function on the GC. And all of you, since now you're all using the same model, so it should be fine, right? All right. Any questions so far about binomial, normal, and Poisson distribution? Okay. Okay. All right. Let's move on to the next part.
What I would do is I'd go like this.
Right there.
Oh, really?
Yeah. What?
No.
Is it about some kind of function?
Yeah.
Calculus?
Function. I actually didn't know how to quit a function.
Oh. Okay. Yeah, communicate with each other. Yeah. You have some nice tricks to play.
It's a hard one to figure out.
Fine, I wouldn't forgot.
Who reads any of those?
So the last part is, well, actually the second last part is calculus. Calculus and distribution. Calculus and distribution. So especially for continuous situation, we know that the area under the curve should be 1, right? Which is 100%. And area under the curve is something we've learned in calculus, right? So Ian, how do you calculate the area under the curve?
The integration.
Yeah, integration, right? It's just integration from a to b of fx dx, right? That will give you the area. So basically, in this case, they can use all kinds of functions that you've learned so far. It could be trigonometric, it could be logarithmic, it could be binomial, it could be a constant, to represent the probability of a certain distribution. And then also, in general, you will see diagrams like this. This is x, that's fx representing the probability. And then it could be just like that. Sometimes it could be even piecewise, like this one. So if that's the case, we know that the area equals to 100%, which is 1. And then let's write down some properties. Area equals to 1 basically means from negative infinity to positive infinity. If it's a continuous distribution, then this is always true. This is always true. You know, if the other part equals to 0, so be it. This statement still stands, right? And then we also know the formula for the expected value, the mu, the mean, which is also the expected value, equals to distribution from negative infinity to positive infinity, or just infinity of x times fx. Okay. And then also the variance. The variance equals to expected value of x squared minus the square of the expected value. And basically that's the integration of from negative infinity to infinity of x squared of fx dx minus mu squared. And then similarly, the median, if you set that as the upper boundary of the integration, that should be 0.5. Right? That's the definition of median. If you let median be x, you just set up this equation into your calculator. Do you know you have just the function, built-in function to find out x? You know that? Are you guys aware of that? Okay, let's figure this out. For example, I just as a practice, right? From 0 to x of let's say tangent x dx equals to 0.5. Well, we know the graph of tangent x is something like this. But let's say we only take this part. No, we know that it goes to infinity. We know this is 0, this will be, what's the asymptote here? Pi? For graph of tangent x? Pi over 2. So if the area is 0.5, we know it should be somewhere around there, if the area is 0.5. But how do we find out that x?
You integrate it, then you plug in tangent x minus tangent 0 for the integration.
If it's paper 2.
Oh, you use the solver.
Yeah, do that. Everyone, do that. Okay? Of course, it's paper 1, you have no choice but to find out the integration of that, but it is paper 2. Do you know how to solve the upper boundary given the integration, the value of the integration?
Numerical solver.
Have a try.
No.
It's still working.
I don't know, I need to make this a different variable.
No, just x.
It's x.
Just x.
Oh, it's the same.
Yeah, I know. They will assume that.
Oh, it's the same variable. It's just
Wait.
Still not.
Well,
I got it from me. No.
it's supposed to be x equals 0.5.
What?
Or x equals 1.5.
Okay, let's see how many answers do we have. Okay, let's say, Aaron, what's your answer?
I just exited the numeric slope ones.
Okay, Ian, what's your answer?
0.779.
0.387.
Yeah, 779.
Okay,
I got
Louis, what's your answer?
Still
Still solving. Steven, what's your answer?
same.
0.779? What's your answer?
X equals
Oh.
0.919.
I got it.
919. Oh, we have a different one.
Negative 0.919.
You got a negative value?
What?
That's new. Okay, I'll just put that.
Oh, I will tell my calculator to solve
What
it
Aaron
one more
got?
time.
0.5 before.
No, I don't know.
Oh, 0.919.
Maybe it doesn't
Okay. Lewis?
Sorry,
Hello? Give me something.
hold on.
Okay, take your time. I'll give you 3 seconds.
It's only a 6 calculator.
Yeah, you have to be familiar with that.
No, the calculator is not solving anything.
First of all, okay, everyone listen up. Whenever you're about to solve a function involving trig expressions, what's the first thing you check?
Mod, whether it's degree or radian.
Yep, what should it be?
Oh,
Radian.
yeah, 0.919.
It should be in radian, right? How do you know it's in radian? Quick
There's
question.
no degree sign.
There's no degree sign. Yeah, you're using a number, a real number as the input of a trig function, which automatically means it must be in radian. If it's, your mode is in degrees, you will get the right answer. And then second of all, for this one, we should all know, since we're using the same model, we're using the function called what?
Numerical.
Yeah, to get this one, we're using numerical solver. Right? Is that everyone has been using? Yes. But, did you know how it functions? Aaron, how many solutions can be provided by the numerical solver? One. Even if it's a quadratic equation, it will only show you one solution. Because the numerical solver, I think we briefly mentioned that. The numerical solver, basically, if you have a solution, right? If that's the solution. If that's, let's say, so this part you need to listen carefully. It could affect the final answer. If we have solution number 1, this is the solution number 2. The numerical solver will only show you one of them. How it works is after you press the solve button, after you press the OK, it automatically pops out a number back. That's not the answer. After you press OK, the number appears there is the starting point, it's the reference point. It's actually, after you press OK, you need to set up a value. You need to basically set up a value of x, and the numerical solver will give you the solution that's closer to the initial starting point. It's an estimation process. Aaron, you see what I mean? So that's why there's a common misunderstanding. You press OK, it pops out a value. That's not the answer. You need to modify that value. In this case, everyone, let's do this again.
Yeah, just plug it back in.
Yeah, start from, you can do that, but you should bear in mind sometimes that doesn't work. It could get another value that's outside the domain of the question. So in this case, we know this value is somewhere between 0 and pi over 2, right? So let's go back to, let's do this all over step by step. Press math, you go to numerical solver, you have the equation, the first one, you have that, right? That's what you have, this page, okay? And then you press OK. It gives you a value that's not the answer yet. You make that equals to, here I'll just make it equals to 0.1. I know it's somewhere around 0.1. And then you press solve. Only after you press the solve button.
Where's the solve button?
Our
Press solve, and then you see this loading. You just wait. Okay, don't press that multiple times. When you see that.
I think it would be much faster if you give it a decimal value.
Interesting.
Given the decimal value.
Like if you, it says tolerance not met.
Tolerance not met. What does that mean? What have you done?
I did this. I said x equals 2 pi over 2, which is this value. And I click solve, and it said.
We should. Because you know what? Because when it's close to pi over 2, it's close to infinity. You're giving the calculator a hard time, basically.
Right, suffer.
Right? You just make it 0 or 0.1. That's pretty good. Okay, and then 3SF. So it's this one. Okay, 0.911. Everyone gets that, right? So the numerical solver can be used to solve all kinds of equations. But bear in mind, just a few more words because this is a very useful tool, but you have to use it correctly. If you have a quadratic, a polynomial equation, this is the solution number 1, x1, x2, x3. If you want to use the numerical solver to get this value, then the initial value should be close to this point. Otherwise, you will never get this solution. Okay, that's the difference between numerical solver and polynomial root finder. Polynomial root finder can give you all the solutions, including the complex ones, right? All of you know that function, right? Poly root finder. Ian?
No.
Try that. So if you have x cubed minus 2x squared plus x minus 10 equals to 0. Use poly root finder to list out all the solutions.
The application. And
And then try that. It's the order is 3. And then you try the complex. It's 1.
I'm gonna try the other two.
Whoa. And maybe 10. Yeah. And then press solve. Gives you all 3 of them.
Wonder if
Yeah.
No. Oh, what's that?
The coins I was thinking.
Oh. Okay,
I'll
continue.
play that if I have
3.
Steven, since you have so much extra time, you can play with it.
what?
Aaron, you use poly root finder to find out all the solutions. Including the
Oh
complex.
yeah, that's what the SL kids do when they get bored.
This one is poly root finder.
Dude, it's our school. When two people get everything back.
What?
I have the. I also only have the X1.
Go back to the whole thing. Go back. Main. Press main. Poly root finder. Did you press A plus BI? Or you only set to be real?
Oh.
Yeah, if only set to be real, it will only give you the real solution. Right? We know that for a third.
Smart.
Yeah, for a third degree polynomial, it could be either 3 different real solutions or 1 real and 2 conjugate complex ones, right? So you need to be fully aware of that. Yes. Yeah. Okay. So that's the difference between numerical solver and poly root finder. The poly root finder will literally give you all the solutions, all of them you want. But this one will only, this is an estimation tool. Right? It will just find out the closest solution, to your initial starting point. All right? Is that clear? Okay. All right. The last part. Okay. Just bear with me. The last part is okay. Let's take away your calculator. So we talked about continuous situation basically involves calculus. And then some tools we can use on the GDC. The last part is we also talk about, the phase theory. Okay, for the base theory, really you just have to follow the definition, follow the formula, which can be found from your formula booklet. It's basically talking about the relationship between different probabilities within a compound event situation. So for base theorem, let's take a look at the probability of B given A can be expressed as PB times P A given B over PB times P A given B plus PB prime times P A given B prime. Okay. So it's a relationship between given A and given B. Okay. Yeah. So that's just for 2 events, and for 3 events, you also have a similar one on the formula booklet. So if it's about base theorem, it's about changing the condition. A is as the condition or B as the condition. Just refer back to this formula and do substitution. Yeah.
Yeah. I was trying to find that.
All right. So everyone, this is the last part of topic 5. Yeah.
3, 2, 1.
No, legends are well copyrighted.
It does.
Okay. It kind of does because the only thing we left is topic 6, which is calculus. I mean, that's actually the one we're most familiar with because we have been doing that practically when we were learning an option all the time, right? All right, so that's topic 5.